Hi, and welcome back to Null Zero Labs. Seeing as my last couple of weeks have been taken up by deploying and testing new internet services, I thought it would be a good idea to go into a video about the types of handoffs or the equipment that's involved in when you request an internet service from a service provider for a business, because it's a bit different to the equipment that you would get installed in your house. So I thought we could go through that. So I'm going to start by jumping into a whiteboard where I've jumped out. I've jotted down some examples that we're going to run through, and then I'm going to run through in the lab two types of scenarios: a managed and an unmanaged type service, and what the requirements are on you as the end user to deploy and get set up with that service. So let's jump to the whiteboard first. And here we are with my lovely whiteboard. Okay, so what we can see here is a few examples of the types of equipment that you would come across that would be deployed into your rack or not deployed in your rack, depending on the deployment option that you're going with, and the types of connections and handoffs that you can expect. So let's start with what we would call a standard unmanaged service. So this would technically be a internet provider service of what you would class as what we would call wires only. So you just get a port and you're able to connect your own CPE equipment to it. From the street to the POP, or to the point of presence, or the telephone exchange, this cable would not go directly there. It goes into a splicing tray that would be underneath here. And then there would be structured cabling, fiber cabling that would go out to the street and make its way through the optical fiber network of the telephone provider of your country of choice, to reach the destination that it needs to go. So this device here, which is normally like some kind of adver device, is like a layer 2 device. It's normally deployed by the last mile telephone provider, used as their testing point where they can verify and say, hey, our fiber is good. There is no breaks between the inside of your building to their test point, etc., outside in the street or at their telephone exchange. So this is their testing point, and this is where they would then hand off to your ISP. So your ISP could either be going to their own managed device directly, like this router, or they could employ their own similar type of layer 2 device. Again, this would be used for your ISP to measure the quality of service. It could be that your service has different VLANs for different use cases, one for internet, one for VoIP. This is where they may split those off into different connections for you to connect to. You could ask for a copper or a fiber handoff. Obviously, the fiber coming in from the street will be done in single mode fiber, and it will connect onto the network side here of their device, and you'll have an access side that will then either go up, like I said, to your ISP's network monitoring equipment, we'll call it, or network termination equipment, or it could be terminated in copper up to this device. So again, you have options, and again, you could then ask for this port to then hand off to you in either single mode fiber, multi-mode fiber, or the handoff in copper. So you have a choice of what you would need to hand it off in. Ideally, if you're coming into a comms room, everything's staying within the same rack, you're only ever going to be 1 gig. You could just leave it that this point to this point onwards is copper. But in some buildings, this point where the local telephone provider comes in, that could be down in a basement of the building, the other side of a warehouse. So getting from this device to the actual rack where you as the end user have your equipment may be a longer distance, so you may require a fiber run from this device to reach your equipment. Up here is when we have a managed service. This would be a single router managed service. Say the provider gives you a managed router of some kind. you would then plug your firewall into the port that they specify here, and they are managing everything from this router back to the ISP. We could have a similar scenario again where you have two providers coming in, going different routes out of your building to different POP destinations. These are all redundantly powered, connected to two different ISP uplink paths, connected to two different ISP supplied gateway routers. And you would then connect this into your equipment and you would be provided a VRRP address, as we have done in similar scenarios. Again, you could not just have the same bandwidth. You may have a site where you would have 1 gig as your primary service and a slower speed to 500 megabit as your backup, because you're only ever going to use it in the event of a failover. So you're likely to see these types of devices installed by your telephone provider, your ISP that you've chosen that works on top of your last mile provider. You have a choice of fiber and copper for connections from their equipment to your equipment. The connection always coming into the building will be on fiber, because again, a lot of these newer devices can support higher bandwidths. Like this one here is a 1 gig service to start with. The only change required for you to step up to say a 10 gig service would be a change in optics. If the equipment in place is capable of handling 10 gig, the fiber can already handle 10 gig. You would only be changing the optical interfaces to be able to support a 10 gig connection. So this is the type of overview of the hardware involved. So here in the lab, I've set up two examples. An example one, which is a managed service provided by the ISP with a last mile provider's equipment connecting into your service provider's network termination equipment to a managed router, and then us as the end user have connected and configured our firewall. The ISP have supplied us with a allocation, a public IP, or they call it a LAN, public IP LAN allocation, that we will use on our outside interfaces of our firewall. There's also another address range that is in use, and that's the uplink between the POPs gateway and your managed router. Again, you have no responsibility for any of these pieces of equipment. You'll have no access to them. The demarcation point is where you connect to on that switch. So everything here is the responsibility of the ISP, the last mile provider. Example two, we have an unmanaged solution where, again, like I said, you will have the POP connected to the last mile provider's ADVA. Again, this could either be coming directly from this port up to your router, but some ISPs are now putting their own management equipment in as well. So it may jump into that equipment and you will then connect into a port on that management device. Now you will be responsible for configuring your own customer premise router, or you could connect your firewall directly, but then you would not be able to make use of your assigned LAN allocation. Now, a couple of days ago, I was doing a deployment and we had our LAN assignment given to us and we wired everything up. We plugged into the port. We were getting no traffic. Now, there should have been a uplink assignment given to us, but there wasn't in the documentation. But I plugged in a switch directly into the port. And what I did then was I did a wire capture, and this is an example of that wire capture here, where I was listening to see what IP address this device had. Because obviously you can use things like the Cisco Discovery Protocol to get information, but mainly you would have that disabled on internet-facing devices, so it's not really that useful. So I plugged into a switch. I was sending this random traffic out, and I was looking to see what kind of ARPs were being sent out via devices. And via this example here, you can see that the NID device was configured with this IP address. This is an example, not a genuine public IP. It was sending out its IP address and it was looking for a target IP address. Now, normally an uplink range is normally in the line of a /30 or a /31 in some rare circumstances. The /31 allows you to use every IP address from that range. So you could use .0, then .1, .2, .3, .4, .5. Whereas when you use a /30, 0 is your network. You can use .1, .2 is the second IP address, and .3 would be the broadcast address, and then .4 would be the next network, and so on. So I started by looking at this, and I could see, okay, it's looking for this address. So once I discovered that, I then decided I would put that IP address on the outside interface of the firewall, point the default route at the other address that was in the wire capture, and the service sprung into life. Now that's because there was a miscommunication in the order and it looks like a CPE wasn't provided for that location. But in this video, we're going to go through how would you configure your own CPE device to get connectivity and set up your firewall and use your LAN allocation. So it's a very simple task, but we'll just run through it. First of all, we'll just test that desktop 13 up here does have an internet connection through its managed service provider, which it should do. I've already tested it. There we go. It does have a link to the internet. It can reach Cloudflare, which is good. So we can see that the one above is already configured for us. So we are now going to produce a similar scenario, but we have access to the CPE because it is going to be our own device. And the demarcation point on this example will be the port on the NID device, the NTE device here, rather than the router. So everything from this line back is in the control of the ISP. Everything from this way forward will be in control of us. Whereas with a managed service, you see that everything up to the port of the CPE device is in control of the ISP. Everything beyond that is ours. So we have one extra device under our control using an unmanaged service. But let's jump into the configuration. Now we've consoled into our CPE equipment here, and what we're going to do is we're going to give it a host name. We're going to start with a host name. We called it null 0 labs CPE. We are going to start by configuring the outside interface. Like I said, again, if you're having an unmanaged service, you will be supplied two sets of public IPs. You'll be assigned a /30 or a /31 that will be used for your uplink. Again, if you are using a redundant service, so you have two CPEs that will be facing towards the ISP, you may be given a larger allocation for that uplink pool because you'll be using VRP addressing to manage failovers. So for this one, we've been assigned a /30. So we know that our int G0/0 is going to be our outside interface. We'll give it a description of to the ISP. And we're going to set an IP address of 192.0.6.2. Because .1 is going to be used by the gateway end in the POP. The address for a /30 is 255.252. I've missed address. There we go. So, and we're going to do no CDP enable because we don't want any CDP running on our interfaces that have public addressing. We don't want them discovered. And no shut. Actually, you could go as far as to specify the duplex and speed and stuff like that, but for simplicity, we will just keep it simple. Now that we've got that interface up, we can test from here to see if we can reach the ISP's end, which is 192.0.6.1. There we go. We can ping the POPs interface over here. So we are reaching as far as there, which is good. We should be able to now configure that we want to do an IP route for all traffic. I need to go back into config mode. We're going to go IP route. We're going to send all of our default traffic towards the ISP. which is 192.0.6. So we're routing our default route for anything that is not known towards the ISP. Now, our ISP has given us a LAN allocation, which is going to be this side. Again, it's still a public IP range. So we're going to go into int G0/1 description. We'll just call this downstream because it's towards us. We're going to give it an IP address of 192.0.5.1, which will be the first one out of that pool to 40 for a/28. So we're going to use the first IP address out of this pool for this interface here. No CDP enable, and we will no shut it. So we've configured our inside interface, still a public interface. We've configured our public interface towards our firewall, and we configured our public interface towards our ISP. Now, because this is technically a router that would be sitting on the internet, it would be reachable from the internet. Now, all IP addresses on this box would technically be public. So you are going to want to make sure that it is secured in a way that you don't want anyone accessing the device that doesn't need to be to access. So if you don't need access to this device over the internet, I'd recommend that you do not enable HTTP servers, you do not enable SSH, and you only access this device via the console cable to keep it as secure as possible. You could, of course, set up a local user, which we should do. So we'll do config T and we'll do service password encryption. We'll turn that on. We will set an enable secret of something highly secure, obviously, but something more secure than that. Let's create a local username. Again, use something more secure than that. We can do our AAA. New authentication model, AAA authentication. Login. We will use a default local. Group will be no group. We can just do local. That'll be enough, and that should get us authenticated. So if we double check, username admin, password was Cisco. And there we go, we're in, and we have an enable password of Cisco. So we are done. We can set our access group for the SSH if we enabled it for this interface, and limit it. So to make sure our device is fully secure because it's on the internet, we are going to set the configuration to make sure we limit SSH access to the device based upon the LAN allocation side of the IP address. So we've set our host name. We're going to set our domain. So our IP domain name will be a null0labs.net. And we've done, then we're going to add a crypto key. We want to generate an RSA. We're just doing just 2048 for this device. We'll generate a key. We will enable IPSSH version 2. And we've already set our username, password, and our enable password. So now we'll jump down into the line. So line VTY. Actually, how many does this have? Let's just show run. don't think this has 15. You'll have to check on a real device. You'll see it's from 0 to 15. This one is 0 to 4. So it's a line VTY 0 to 4. The transport input is going to be SSH. We're going to do a login local. We have already indication. Default will do because we set it to the default one, and we will do an exec timeout of say 5 minutes. Timeout is a minute, yes, 5 minutes. And next, let's create a access list. So the access list, let's call it access list 1. We will permit, what was the subnet? The allocation was 192.0.5.0, I think it was. And we will allow access from, now this is where we're going to need a subnet calculator. Wildcard mask calculator. Oh, is it one thing? Okay, so it was 192.0.5.0/28. So our wildcard mask will be 00015. There we go. 0.0.0.15. And that should be it. And then we'll go back to our line. BTY 0 to 4, and we will do our access class 1 inbound. And that will now secure our SSH to only allow access from our allocated LAN side. That should be enough to get our CPE functional. So now let's get our firewall online. So let's connect to the firewall and make sure it's got a management address. First time you connect, it will ask you for that. Show interface management. That should be, oh, there we go. Show interface management. We can see we've got an IP address 168.159. Okay, let's just commit that. Commit that because the password is changed, and we want to go to 192.168.68.159 as the management. 192.168.68.159. There we go. This will give us our firewall. We'll log in with our new password that we committed. Probably still committing. Yes, we'll wait for that to change. So this is like the perfect example of static routes where we have added a route to say anything that this router doesn't know about, send it to our ISP's gateway, which will then use its routing tables to find its route to where it needs to go. Obviously, this LAN allocation is available on the other side of this address range. So our ISP is saying, hey, if you want to reach this block, it's on the other side of this gateway. And as they've assigned a /30, they know it's going to be on the other side, which is .2. So let's now log in here. Eventually, I'll learn to type properly. So we have our fresh firewall. Okay, all of that. let's start with the basics. Let's get our outside interface configured. So it's a layer 3 interface. It'll be part of our default router. We're going to give it a new security zone, outside interface. We're going to give it the IP4 address, which was 192.0.5.2, because this is 5.1. So we're going to be 5.2. And it was a /28. We will allow ping on the outside interface just for testing. Ping only. Then we'll hit OK. So that gives us our outside interface. We will configure our inside interface towards our real private LAN. So this will be our LAN. We will give this part of the default router. Again, you've all seen this done before. This is a very simple inside, outside firewall. Our inside address range would be something like 192.168. Let's do 90.254 for the gateway /24. So we've given that. We will allow our users to ping that interface so they can test it, they can reach it. So that's our inside and outside gateway done. We need to do again our default route because we're not doing any dynamic routing. So we are going to default anything subnet out of interface 1, and our next hop address is 192.0.5.1. So as you can see, there's a chain. So we're saying anything that you don't know about, you have to send it here. This one is already saying anything I don't know about, send it here. And this one will have full tables with BGP routes that it's receiving from other ISPs, other internet exchange points, and your traffic will make its way to where it needs to go. But in this term, it's a very simplistic path, so it's all done with a static route. So we've done our static route. We've done our interfaces. We need next a policy and a security rule. So we will add a NAT, and we will say our source NAT. So this is the one that we're going to NAT all of our traffic from our private subnet from the inside to our outside zone, going to any address, and we are going to translate it to one of our interface IP addresses, which was our public IP of 5.2. Next, we will add a security rule, and we'll call it internet. And we will allow anything from our inside. We have a source address of 192.168.90.0/24, I think we said. And we'll allow it to go to the outside interface, any address, any service, any application. Obviously, we can restrict this. We can say we'll only allow ping. We'll only allow HTTP or web browsing. Web browsing, SSL, DNS, just to be secure. So we'll allow those and we'll allow it. So we'll click on OK. We'll hit commit. Oh, actually, before we do that, let's do one other thing. So let's do a DHCP server for our inside. So let's add a DHCP to our inside interface. It's going to be enabled. And we're going to add a pool of 192.168.90.10. to 192.168.90.20. That'll be enough for our use. The gateway will be 192.168.90.254. Subnet mask, and we will do 1.1.1.1 for our DNS, and we'll use Google for our one. We'll click on OK. Now we'll commit that. So that will configure our firewall side that we've done. We can start up our desktop over here. So we've configured our CPE with a uplink address, a LAN, public LAN IP range on the other interface. We've set a route to go towards here, which is the ISP's gateway, which we would have no access to. We've configured a username and password and an enable password. We've disabled CDP. Open our desktop over here. Let's see if we have given internet access to our... Why are you not working? Let's have a look. Basic diagnostic, we have an IP address. So let's ping 192.168.90.254, which should be our gateway, 254 even. Yes, so we can reach the gateway. Let's ping 1.1.1.1. And if I come down here to the default internet zone, you can turn this on. We can see that stuff's being denied. So let's have a look at what is being denied. If we click on that, we can see obviously it's blocking based on the application base. So we need to allow Google as an application or change our rule. So what we can do is we can allow Google base. Click on OK because we're blocking via applications. So if we click on that and commit it, we will then be able to reach Google. But we're not using that. So Google base should be enough just to get us the Google web page. So this is what happens when you really start to lock down your firewall. You really have to start looking through the logs to find which applications are blocking, especially with the Palo Alto, because it does it based on application. So it will go as granular as knowing this isn't Google application. You can allow access to Google search, but you don't want to allow access to, say, Google Drive. There we go. So now that we've accepted it on the firewall, we can now reach the Google search desktop. So we should now see if we go back to policies and we have a look at our internet rule. We have a look at we can see that we're allowing quick base and we're allowing DNS base to go through, and we're allowing SSL traffic, which means we're also now allowing Google. So we should now be able to do a search. Nozeralabs.com. There we go. We get the search results all working. So there we go. With you could technically drop this out and we could put this on here and we could then NAT. So let's, just for a bonus, let's just show that. So if I stop these, I will stop this one. We will delete this connection and we will delete this connection. Say you didn't want to have to put a CPE in. You could put this on the outside interface here, and you could then add this as a NAT pool on your firewall. But again, this is now going to be dependent upon your firewall being able to support this. If you're using something like a Meraki or some smaller device, it may not support NAT outbound in the format of doing a source NAT. It may work for destination NATs, which are inbound, but it may not work on this front. So let's make some changes to this firewall. So our rule out to the internet will stay the same. Our NAT will change in a minute. So let's start with our interfaces. So on our interfaces side, where our internet one was we're going to change the IP address to the one our provider was using. So 192.192.0.6.2 was the address. So 192.0.6.2/30. So that gives us that. .1 is obviously at the pop. So we're going to hit on OK. So we've now done the uplink there. We could then jump over to our virtual router. We can jump in here. We can do a static route. I'm going to update our static route. And instead of us pointing to our LAN range, we're going to use 192.0.6.1, which is where we're going to point to. So what we've done is we've taken the IP address that was on this side, we've taken the IP address that was on this side. So we've removed this IP address from here, we've placed it on the outside interface of the firewall. So it's going to be 192.0.6.2, and up here we know is 192.0.6.1. We've set a default route from here to here. And finally, we will use our LAN pool we will use the address from that to NAT our users traffic out. So we've done our default route, we've done our interface, we're going to come back over to our policies, and now our source NAT, instead of us translating it to the outside interface address, we are going to translate it to an address, and we are going to use 192.0.5.1, which was our first address in our original LAN pool. So anything going out to the internet will be natted to this. Now we'll hit commit. And now what we'll do is, once that's committed, I'll shut this firewall down and we'll connect it to our demarc port on our NID. And we'll see that everything will function again as well, but without adding an extra router. And like I said, obviously you can only really do it this way if you have a firewall that supports doing NAT pools for your outbound NAT and being able to manage the IP range appropriately. If not, you will have to go through this route of deploying a CPE device. Right, there we go. So now it's wired back up directly. So now what we've done is we've disconnected our own CPE. We've gone directly now from the provider's NID to our firewall. And thankfully we have a high quality firewall. And we made a change. We moved the uplink address onto the outside interface. We changed our default route towards the ISP. And we updated our NAT policy to use one of our LAN pool IP addresses. So now desktop, we can see we are now reaching the internet and we are able to reach Google, etc. Let's just double check that we can reach Google. Yes, we can. There we go. So we have internet access. Everything is functioning, but now we have removed the CPE. We have connected directly to the firewall. So this is the two ways you could do an unmanaged service. But like I said, as long as your firewall supports the ability to go in and do a source NAT where you can say, hey, anything going out to the internet should use one of these addresses that I've been assigned as my LAN allocation, and you can then assign your uplink. If not, you will have to use a CPE device to connect the /30 address to your router and then use your LAN allocation towards your firewall to complete that connection. We can see that the traffic is going out from the source machine on the LAN to 1.1.1. And if we have a look at the details and the natting section, if I can find it, there we go. We can see that the source IP address comes in from the LAN side of the user. They are then natted to the IP address. And then they then take the outside interface towards the internet using that IP. So there we go. We have successfully configured our unmanaged location twice. We've configured it once with a router and once direct to the firewall. So I thought that was not really too far off topic from what I've been covering most of my past couple of weeks. Like I said, the ability to be able to plug a switch in sometimes to use Wireshark to be able to sniff packets, to be able to see what's going on is very helpful, especially when it comes down to points when you haven't got all the information to hand. Luckily, using that technique, I was able to discover what the uplink IP address range was, and appropriately assign it to the device to get our equipment online. It's up to you what sort of services you look to obtain. A managed service, know that you've got a high quality router in front of all your equipment. You know that it's managed, you know it's supported. Everything from that point towards the ISP is under their control. They can get access to it, they can run tests, they can also verify things, they can make changes for you. When you supply your own equipment in front on an unmanaged service, you're responsible to make sure that you secure it, that nobody can get access to that device because it is sitting on the public internet. You then have the ability of going, oh, does my device support using an uplink interface on the WAN side? And then can I allocate my LAN allocation to allow my users on my LAN to go out onto the internet? Do I need to supply a CPE myself? So there's a lot of questions you need to look at, and there's a lots of pros and cons with both sides. But I thought it was just a video just to show off some of the ins and outs of it and show you and highlight some of the technologies and the different devices that are deployed when using these setups. I hope you found it useful. If possible, you can hit that like and subscribe button, and I will see you on the next one.